Yeah, I have no idea what's happening. I gave it like a minute or two, and I started the stream again. So hopefully, maybe this will stick. But anyway, what I was explaining before I got cut off a few times is that we're starting this episode using planning. So I'm making just a whole new project, and with this project, we're going to just be working on a planning algorithm. Eventually, I use this planning algorithm to solve the Sokoban problem, so it tells you the solution to the level. But we kind of need to build a planning engine. So that is what I'm going to do now. And so it's kind of mixing my schoolwork and my game together in one. So hopefully, stream stays good and I can work on this stream. So here we go. Just gonna make a scripts folder. And this is not where I should start, but this is where I am starting. We're gonna make a plane graph. And so a plane graph is gonna contain plane graph levels. So I know it's making all sorts of like Unity type C# scripts, so we're definitely going to be changing all of that, but I just want to kind of get some framework here. So we're going to have a plane graph, it's going to have plane graph levels, and just a quick explanation what a plane graph is. Maybe we can just find an image on Google, plane graph, images, plane graph with levels or something. Cake domain. Would that help? I see that. That's the cargo problem. That's from the paper. Anyway, this is a plane graph of a cargo problem. So we have planes and then we have cargo. So we have a plane at London, a box at London, and we have plane A at London, plane B at London, and a rocket. Oh, package A at London, package B at London, and a rocket at London, and then fuel for the rocket. I'm gonna kind of ignore the fuel for it. So the actions we can take is load the cargo in London, and that loads it into the rockets, I believe. Load the cargo in London, which will load it into the rocket at London. And move the plane from London to Paris. So basically, this is kind of what this does. It builds this graph of actions and effects, and it builds it until you reach your goal. And in our case, for Sokoban, the goal would be to get all the boxes onto the targets. But you can have tons of different domains. So that's what we'll look at first. We'll look at the PDDLs of just some sample domains that we've been looking at in class. So let's go ahead and pop that open, and I have that in Java right now. And so here we go. One's going to be like the domain of the problem, and one's going to be the actual problem. So let me just, like I said, I'm going to try to copy this over to my new project. So here's all the PDDLs. We're going to move this over into Unity. Maybe I can even have like a PDDL or problems folder, and we can just copy this over here. Alright, cool. So Unity doesn't really know what these are, and that's okay. What if I double click it? It'll just, yeah, it doesn't know what to do with it. That's fine. What we're gonna do is look at them in what am I trying to say? Look at them here in Visual Studio. So okay, so our goal right now is I'm trying to program the plane graph. So if I go back here, I'm going to try to program this structure. So the plane graph is going to be this entire structure, and then this is going to be one level, this is going to be another level. So time 1 basically, time 2, and time 3 are going to be my different levels. So that is how I'm going to handle it, and then we're going to have a class for actions and a class for basically effects or expressions. Okay. So here we go. I'm just go ahead and launch Visual Studio, and we will see what to do from there. And hopefully this loads up quicker than most of my other times. Not that I did anything different, I'm just hoping it does. Okay, and it did. Alright, so a plane graph. Like I said, I'm not going to make these actual Unity objects. They're just going to be straight up C# objects. So because I did this not too long ago, I kind of know what I want to do here. We're going to have a list of steps. I'm thinking, just give me 1 second. Yeah, okay. We're going to kind of do this the less efficient way, but I figure since I'm just doing this in C#, it should be alright. So we're going to have... We're going to name this differently. So we're going to have a list of actions. I don't like using actions though. Steps is fine. Step, and we're going to have a list of facts. So here we go. Facts. So it's complaining at me because we're not including any of these generics collections, and then we're gonna have to make that step into facts. So I'm gonna go ahead and say, yep, generate a class for step in global namespace. Oh, it's not even using any kind of namespace. That's too bad, but whatever. Maybe I use a different namespace. Maybe I actually put it in something like namespace playing graph. Okay. And then hopefully you will generate a new step in playing graph. You can generate a new fact in playing graph. Okay, I'm feeling pretty good about that. So when we create a new plane graph, for now, this is just an empty plane graph, we're just going to go ahead and initiate basically a new list of steps and a new list of facts. Okay, excellent. So that's great. These are going to be used later, so actually I won't even do that. But what I will do is have a list of playing graph levels, and we'll just call this playing graph levels. And then for now, playing graph levels equals a new list of playing graph levels on the initiation, and that's all we're going to do for now. So from the playing graph we can get different things. I don't know if we'll call it current or max level, but let's just go ahead and say public get current, we'll call it max level. And so that's basically just going to return playing graph levels dot get. If not, you can just do this return. Oh, and I'm not actually, make sure you return a playing graph level. So this is going to be basically the playing graph levels dot size dot count -1. Okay. Public int get level count, and that's going to just be how many levels are in here. So that's basically playing graph levels dot count. And we can actually just say get level count. Excellent. Alright. So something like this so far. So this is the playing graph. This is more for optimization, so I'm going to take it out for now and we'll probably put that back in later. So this is the plane graph. Plane graph levels will be here. It's going to be in the same namespace, plane graph, and we won't have these updates functions. You won't be a mono behavior, so you probably won't be using any of that, but you are going to be using a list of steps, and it's going to be steps, and yep, you'll be using a generic list, list of fact. So here we go, facts. Okay, so we got a list of, we have a plane graph with a list of levels, and the list of levels have, each level has steps and facts. So far, so good. What do we need to do now? So okay, this is going to be the root level, and all this does is just say, and with the root level, I just want to turn in the problem. And so the problem is going to be something we get from the PDDL, basically. So generate class for problem, sure. Okay, so steps is going to equal a new list of steps. Facts is going to equal a new list of facts. And for now, the problem is going to equal problem. Excellent. Public, so we're going to have a function called contains, and we'll say does it contain step, and all it does is just check step.contains step. Awesome. And this will be a bool, I guess? A boo. A bool. So we'll go ahead and return that. It doesn't like this because why? Inaccessible. The parameter type step is less accessible. Oh, so step is it's gotta be public. Cool. Okay. And public bool, same thing. Bool contains fact. And this just returned facts that contains fact. And I'm guessing fact also needs to be public. Excellent. Looking good so far. So how this is gonna work is steps.add range. We're gonna go ahead and add range, and or let's see, add initial facts to add initial facts, and then we just get the problem. And basically that's gonna modify to do add all facts that add problem dot initial facts. I don't know yet. Initial expression. Yeah, there's some work to be done here. But for now, yeah, we'll just say facts.add add range problem.get get facts or get initial facts, something like that. And of course we'll just go ahead and add that. So another thing I did here is I have another plane graph level that computes mutexes. So plane graph level mutex. And so all this does is what? It extends plane graph level and basically we get some dictionaries or a map, a heap, not a heap, a hash set. Let's stick with dictionary. And so the dictionary is going to contain, let's see, it's going to contain a step and a list of steps. And we'll just call this mutex steps. And then we kind of do the same thing for facts. Fact, mutex facts. Okay. So we'll definitely pass the problem. So it does base.problem, and all it does now is mutex steps equals a new dictionary, and mutex facts equals a new dictionary, and we will basically add all the mutexes, or compute all the mutexes here. So to do compute all mutexes here. So okay. And the other functions you will return is mutex step and other step. Yeah, that sounds good. And you just return, I'm gonna just return false for now. Public bool is mutex step and other step. No, we should do fact, other fact, return false. What about this? Is that all I need from the mutex part? Maybe. I think so. Okay. Really, the meat of this is to take the initial problem and kind of, what am I trying to say? Yeah, take the initial problem and just go to town with it, figure out what the mutexes are. So I'm going to make those protected. All of this is private. So yeah, I'm going to try to be more explicit with my, security or level or whatever this is called. Okay, so we have a playing graph. It makes a new list of playing graph levels. What we need to find out is how to get this problem sort of working. So this problem is going to be, if I can kind of see all the folders, how to show all files. If you don't mind including the problem, if you can include this in the project, hopefully it includes everything in there. Okay, and then I can stop this. Alright, so here we go. Here's the cake PDDL. So, okay, yeah, I just wanted to explain this before I got too much into it. So this PDDL starts with domain. So this we know is going to define the whole domain. And so the domain name is cake. And now we have this action. So this whole thing is going to define an action. So an action has a name. So it's going to be called bake. The parameters is it'll take a cake, type cake, and it's going to take cake as the name of the parameter. And then the precondition is not have cake, and the effect is have cake. So that's how you get cake. And then you have eat cake or eat. And so basically that is the action is called eat. The parameter you put in is a cake, and the precondition is you have to have the cake, and the effect is after you eat the cake you won't have the cake, but you will have eaten the cake. So can you guess what the problem is? So the problem for this is, hey, initially I have cake, but I want to have my cake and I want to eat it too. So this problem is basically how do you have your cake and eat it too? And the solution, spoilers, is you eat your cake, you bake a cake, and then now you have a cake and you've eaten cake. So yeah, simple little problem, but a good little test problem to start off with. So we start with that problem, and then we'll work to the cargo domain, and then we'll work on the Sokoban game, and then we'll kind of have this whole thing working. Alright, good deal. Anything else? Nothing I can think of right now. Our goal is to kind of take this, where am I? Basically, we want to take this domain and this problem, and we want to make it into something usable in the code. So that's where I got to kind of dip into, in the essence of time, I'm going to dip into my instructor's work here. So we have different projects here. One of them is the state space. And that's not where I want to go. Planning. Here we go. So planning has this problem class. And this problem class has a domain, which I will probably do in ours. So we're going to say private domain. And we'll just call it domain. And we will make that class as well. Okay. I guess we'll call it a name. Yeah, we'll give it a name too. He's making everything public. I think I'm gonna make everything private and just have make everything private but have properties to access them. Kind of just a different philosophy in the C# programming versus Java, I guess. Okay, all the objects that exist in the world, so that's pretty good. And he made an immutable array. I wonder if I could do something like that too. I really would like to. Private immutable array, and we'll have what object? Oh, a constant. Yeah. So we're totally going to be stealing a lot of this stuff. So we're going to generate a constant. We're going to generate this immutable array. How do I do this? I can't just generate it like that. Yeah, it just doesn't even know what to do. I'm going to generate a class for immutable array. And this is going to be of type constant. And we'll figure it out from there. I'm going to delete this one. And I think I could just do T like this here. That's the use of generics, and we'll look into that in just a bit. Where was I? I'm doing the problem, right? Alright, I'm gonna open the problem, I'm gonna close everything else again, all but this. Okay, so I definitely like all that. The name, domain, objects, the initial state. So, initial, that means we're gonna need a state object. I'm gonna just generate a new state object. And an expression. And this is a goal. Okay, so this is what we got: a string, a domain, a mutable array, state, expression, goal. So all that's great. That's what we need. I know this just seems like duplicate work, but I really like this format because you don't get to modify any of this, but we can just say public string name, and we can just say get. Oh, yeah, sorry, I screwed that up. So name, and here we get a get, and then we can just say return name, and then close that up. And then we just do that for each of the properties, like domain, objects, initial, and goal. And then we just go ahead and name everything. Domain, objects, initial, and goal. And we just make sure that the types are correct too. And then we make sure we're actually returning the right thing. So that's going to be domain. This is going to be objects. This is going to be initial. And this will be expression, no goal. And somehow not all of this is working. Oh, yep, all these things are internal and not public, so let's go ahead and make them public. Public. Oops. Keep going to the wrong thing. And you're gonna be public. Okay, so here we go. What's going on here? And maybe constants is not, yeah. And that's not a capital P. Alright, cool. So our problem is taking shape. So, okay, the constructor of this seems pretty easy because it's just going to pass all this in. So I'm just gonna type it all up. And then this part's pretty easy. Say name, domain equals domain, objects equal, oh yeah, I could have just typed that. I put the S on there for a reason. And initial equals initial, and goal equals goal. Like that. Okay. Yeah, I guess I can. I don't know what's better, to throw that? Yeah, I guess throwing that would be better. Not implement it yet. Okay, cool. So this really duplicates what the Java does, right? There's some helper functions in here, I see. You can just array an array of constants, a hash code, that's pretty cool. Is solution, checks if a given plan is a solution to this problem. Oh, nice. Get objects by type, and toString. Okay. Nice. I guess I can kind of do that too. Public override toString, and we're just gonna say string.format. We're gonna say 0 in 1, and this is gonna be name and domain dot name, which I know doesn't exist yet, but guess what, it will. So let's just go ahead and put that in right quick. So this would be private string name, public string name. It's gonna get get return name. All right. So got the toString. I haven't done anything else yet. We'll come back to it. Let's see if we can figure out how the problem comes to be. So I'm going to go to benchmarks. We go to source. We go to main. This kind of makes the problem. So problem is being made by benchmark. So let's go look at benchmark. Benchmark. Don't know why it's called a benchmark, but we'll figure it out. I'm just gonna call this PDDL reader for now. So let's go ahead and make another class here. I think it's Control-Shift-C. Uh-oh, where's my mouse? Control-Shift-C. That's class view. Not what I want to do. Maybe Alt-Shift-C. Yeah, Alt-Shift-C. And let's go ahead and make PDDL reader. Okay, so we have PDDL reader. And the namespace is no good. No bueno. No bueno. So we got plain graph public class reader. So the reader, what we'll do is private string We got domain and problem, right? Domain private string problem. Alright, so we're gonna get a string domain and a string problem. So let's be a little more specific here. Let's call this domain file name, and we'll call you problem file name. I like it. So we're getting the file names here. So domain file name, oops, domain file name equals domain file name, problem file name equals problem file name, and then when we actually do this public problem, and we'll just call this get problem, and let's see what happens here. We're going to need a parser object, which I think is going to be the hardest part, equals new parser, and we're like, what are you talking about? And parser is probably under utilities here, or logic, or IO. Yeah, IO makes some sense. Phew. Yeah, so yeah, that looks rough for me. But I am totally gonna steal some of this. Alright. Do we have a throw not implemented yet? Not implemented exception? Something like this? I think it needs a parentheses. Alright, cool. So I'm not there yet. We'll get there. But we do need that parser. That parser is key. And let me just see if it's doing anything else that... This might be the last thing we need to do. Gosh, yeah, this parser it's what's gonna be the hard part. How do we parse? Basically, how do we parse this into a problem object? And so there's a lot of components, right? We got to make all the objects, we got to make all the predicates, and all sorts of different things. And so I feel like parser is gonna make a lot of different objects too. So I might break this up a little too into different folders, just kind of like we have it over there. One will be just for planning. I kind of like this breakout. I'll just kind of steal this. So we have a planning area, and just these two is fine. Planning and a graph plan planner. Okay. I feel good with that. Yeah, it's getting kind of late. Let's start wrapping this up a little bit. And to do that, what I will do is, for our PDDL reader, I'm I'm just going to say parser. PDDL parser. Parser equals new PDDL parser. What are we passing in when we do it here in benchmark? We're going to parse. So basically what you're doing is you're parsing the domain.class. Yeah, how's that even work? How do you, what? I'm so confused. Alright, so, yeah, so parser is blank is just doing that, and I think you do that, right? In benchmark, you just make an empty new parser, so you register all that. Domain.class. And we say register. What do you mean, register? Interesting. So you actually like kind of make, you kind of just getting the class of that. So it's kind of like the type, right? In C#. I'll figure that part out. But then when you say, hey, give me this is it. Give me the file name. Do you have just a file name? Because I don't think we're actually opening the file. Oh yeah, we are. New file. Okay. So we're passing in the file and the class. Gotcha, gotcha. Okay. It's kind of making sense. So PDDL parser, generate class for PDDL parser, yeah. And then we're gonna say, hey, parser dot parse domain dot, can you just pass domain? That'd be interesting. I don't know if I'm gonna do file or how am I gonna do this. Okay, stream reader maybe? Stream reader. Yeah. Crap. I don't know. Do I just put in the file name? Using stream reader equals new stream reader. I'm just gonna go domain file name, and then we'll just open this up, close this up. Trying to get this right, and then we'll just say stream reader. We're gonna pass the stream reader, and we're gonna pass the can we just pass domain? I saw it. I didn't click it though. Generate PDDL. It's not exactly what I do. I want to like return a class or something. I don't know. Is that right? I don't actually know how to pass classes in C#. Let's go look. Let's look that up right quick. C# pass class type. Yeah, how do we pass a class type as a parameter? Type. That's what I need. So if we go back to parser, PDDL reader, do I just say domain.type or type dot get type domain? I guess. Is that right? I don't know. Oh, type of. Duh. Type of domain. Something like that. I think that's right. Okay, so definitely be doing that. I'm going to try to do this without the parentheses, see if this works at all. What do we do for the second line in benchmark? Okay, we just get the problem. Okay, cool. Oops. Where's my Visual Studio? Okay, so we do something similar, but instead of this, we do problem. And instead of domain file name, we do problem file name. Why do I feel like it should be the same, but it's not the same? Something's not right. Parser.parse. Oh, it's a void. So what would you do? Phew. This generics, crazy. I gotta learn how to use generics. That is definitely a big gap in my understanding right now. Um, I'm thinking. Hmm. I gotta look at generics. I can't. I don't know what I'm doing. So yeah, I will come back to this. So definitely not implement it yet. We're getting there. Might have to redo this a little bit. So yeah, that's a good first start. I'm gonna be doing this again. So it's just a lot of like coding and planning and maybe not exactly completely game development at this point, but definitely fun if you know what you're doing and you understand the overall concept of what I'm doing. So we're going to be making a plan graph, but to do that, we're going to try to extract the plan from this PDDL file. So our problem right now is we have cake and we want to eat it too. So to do that, we have to eat cake and then bake cake. So yeah, it's going to take some work, definitely a couple hours, but it'll be worth it at the end. And the plan for this part of the project is just to make a visual. So the visual is going to have different nodes, and you'll see how the cake problem gets solved using different algorithms. So that is my first plan, and I'm going to make this all in Unity and Visual. So hopefully it all works. But I need to get the base working first, so that will take a couple of hours. So I know it's all under Sokoban, but it's gonna come together. It's just kind of a detour and then coming back. So we went this way, and then we'll come back in a couple episodes. So all right, bye guys. I'll catch you next time. Yep, I'll post this on YouTube.